Hello, this is a demonstrator to show how easy it is for Jiva's agentic AI platform to build an AI to predict when a machine will fail. So here we have just gone over to Kaggle and we have managed to find an open data set which has a machine predictive maintenance classification project. So what we have, and it's got a usability of 10, and you can see the feature columns that we have. So things like air temperature, process temperature, rotational speed, torque, tool wear. Finally, did it fail or not? And actually, we can even predict the type of failure. In this demonstration, we're going to be predicting failure or not. So here is the data set. And without further ado, I will jump onto our platform. And I will create a workflow predicting machine failure. And how our agentic AI platform works is via nodes. And if you imagine these to be the backbone of the platform, so here are all the columns. So first of all, where is the data? Is it online? Is it an RSS feed? Is it a software? Is it a database? So these are all nodes that link to different places to grab the data. And then, of course, once you've grabbed the data, you may need to convert it to make it a bit more amenable for machine learning and AI. So these are all converter nodes. Engineering nodes. So, if you need to rescale or segment images, you can do that. If you need to change columns around, if you need to get data from different areas. So these are all the types of nodes that can do things like that. Model training. So we are an agnostic generalized AI platform. So it doesn't matter if you want to do classification, regression, large language models, NLP, intelligent document processing, image analysis. We can do all of those quite easily within the platform, all using no coding and all within a fraction of the time and the costs. And these are the nodes. In fact, we've also got AutoML. So those type of nodes where you can test several different models quickly. And then decision tree. So you might want to take the output. So say we've predicted when the machine is going to fail, you might then want to email the factory floor supervisor and the maintenance company beforehand to let them know that, look, there's a good chance that this machine will be failing soon. So we'll show you a bit of that. So we're going to jump into the platform. So the first thing is to download the data set. And I believe we've already downloaded it. You can see I've been making quite a lot of machine AI models recently. Where is it? There it is, predictive maintenance. So we'll just have a quick look at it. There you go. Product ID, incident number, type of machine, air temperature, process temperature, rotational speed, torque, target, did it fail or not, and why, what was the reason for failure. So I'll just bring that into our platform. Next thing I'm going to do is just shuffle up the data. It's always good data science practice to shuffle up the data to make sure all of the failures and non-failures are not all grouped together. Next thing, we need to define what we're looking for. So define the inputs and the targets. And in this case, I'm just going to select all, but I'm just going to take away the target, incident number, not important, product ID, not important, and failure type, not important, because we're not looking at that. We're trying to look for if it failed. Although, if we want to look at predict the failure type, we can do that using another pipeline. So it's not difficult to do. And finally, what are we trying to predict? So in this case, we're trying to predict whether it failed or not. Next, we're going to introduce a one-hot encoder. And what we're going to do here is the non-numerical column, which was the type of machine. We're just going to encode that into binary or numbers. And what I also want to do is introduce a discard incomplete node. So any columns or rows that had incomplete data, I'm just going to remove that row altogether. Next, I'm going to introduce a min-max normalizer, and this normalizes columns with large variation. There you go, min-max normalizer. So anything that had large variations, I'm just going to normalize all those columns. And next, I'm going to introduce a type of AI called a gradient boost. I'll use the first one this time. I'm just going to turn my feature importance on. And make it 10 deep. And then I'm just going to connect all my nodes. And just to show you, today I've done it, believe it or not, we can do it even faster than I've done it. And what I mean by that is today my objective was to show you the backbone of the platform. But actually, next time you might think, I don't need to know that, let me do it even faster. And for that, we have templates. So all of these templates do something different. So you can see it will build the whole pipeline for you. You just fill in the blanks. So in this case, summarize the contents of the PDF file. And then you've got lots of tabular data. So if you want a k-neighbor, a classifier or random tree for it, classifier, you've got all of these different types of templates. And each of them have a different pipeline for a different type of AI, as you can see. Yeah. And the next thing I'm going to do is just press run. And here you can see in under a minute, we've managed to complete our pipeline. Let's have a look at the results. So you can actually see that within under a minute, using our gradient boost classifier, we actually built an algorithm that was 100% accurate at predicting when a machine would fail or not. So that's the speed at which you can build AI models using Jiva. Thank you for watching.